the magnetic effect of a current. Simply put, does current produce magnetic effect? When you look closely here, it's a compass. So we want to see proof if current can produce magnetic effect. So now, this is a wire that does not carry current. And this is what happens. The directional compass will be in the normal position, north, south. But when you allow current to pass through, this compass will deflect at 90 degrees to the wire. Now, why is it deflecting? Because it has experienced the magnetic effect that a wire has produced. That is one evidence. The second evidence is this. What you only need to do is you get a cardboard. Then on the middle of the cardboard, you insert a wire. Then you sprinkle iron filings on the cardboard. Then what happens is you allow current to pass through the wire. Then you tap the cardboard. You tap it. Now, when you tap it, what happens? The iron filings arrange themselves in a circular manner like this. So you can find out the direction of magnetic field and the direction of current by using a right hand grip rule. So this is what we mean. So this thumb points in the direction of current and the fingers point in the direction of field. So when I hold like this, you've seen the way he has held the wire, meaning the current is moving upward and the magnetic field is moving in the anti-clockwise direction. That is anti-clockwise direction. Another evidence is a solenoid. What happens is, for a solenoid is just a magnet when current is passing through it. So what happens is when you allow current to pass through the wire, this thing, which is a soft iron, become magnetized, become a magnet. So meaning that current has produced the magnetic effect. So you can find out the polarity of this bar by using a right hand rule. So when holding like this means that the fingers are pointing in the direction of current, but the thumb is pointing in the direction of the north. So this shows that the north is this side, but the south is the other side. That is one other evidence. Another thing that you can do is just a simple thing. Okay. What you can do is you allow current to pass through a wire that is between a permanent magnet. So this wire will begin moving up and down. Why will it be moving up and down? Because it will experience the magnetic forces. So now you can find out the direction of the force, where the wire is going, the field, and the current by using a right hand. So the Fleming's left hand rule, like the one you're seeing here. So if you see properly here, the thumb point in the direction of the force, then this first finger point in the direction of magnetic field, then this point in the direction of current. So for example, if I put my finger like this, meaning the current is moving like this, the magnetic field is from north to south, then it means the wire is moving upward. So that is another way of showing the magnetic effect of electric current. Now this can also be shown on what we call a DC motor. Now when you look closely at a DC motor has this, and that's how you know that it's a DC motor. So these are commutators. Then these that you are seeing are brushes. Now what is the function of brushes? Brushes is a passage for current. Remember that current, when it comes, it has to pass through the brushes, then move to a coil. Then the commutator here, the function is just to ensure that current flows in one direction. So what does a DC do is, when current is passed through this coil of wire, this coil of wire starts rotating. So in other sense, a DC motor converts electric energy to mechanical energy. That's what you should know. So the idea is making this coil rotate, okay, by the flow of current. Why is it rotating? It's because it is experiencing the magnetic effect there. So the question that we may ask ourselves is, how do we increase the turning effect of a coil when it is rotating there? So the turning effect of a coil can be increased by, one, increasing the current, that is number one, that is flowing. The number two, using a strong magnet. The number three, increasing the number of turns of the coil. The number four, increasing the area of the coil. So when you do that, it means you're increasing the turning effect, or the turning effect of this coil of wires. Thank you for watching.